Hi, Mr. Pepperell here, and today I am thinking about how energy is transferred in an electrical circuit. Hopefully by the end of this video we should be able to say a little bit more about the electrical energy supplied by a battery and the electrical energy supplied to the components of a circuit. So, to wrap up our work on electrical energy and charge, we're going to have a little think about where the energy actually goes in a circuit. So, looking at this circuit here, we can see that we've got a 12 volt battery, more than one cell joined together in series there, okay, connected in series with a bulb and also in series with a variable resistor, and then back to the power supply again. Okay, now I've got a voltmeter there connected across my bulb, and looking at my voltmeter I can see that my voltmeter is reading 10 volts. And from what I know about components in series and potential difference, if the potential difference across my bulb is 10 volts, then the potential difference across my resistor is going to be 2 volts. Okay, so I know a little bit about my circuit, so what can I say about the energy being transferred? Well, I know that each coulomb of charge that leaves my battery carries 12 joules of energy. How do I know that? I know that because of this equation that we've met before. Energy equals potential difference multiplied by charge. The potential difference of my battery is 12, and I'm talking about one single coulomb of charge. Okay, so if I put those values into my equation, you can see here that potential difference of 12 volts multiplied by a charge of 1 coulomb, 12 multiplied by 1 gives me 12 joules. So I can say for each coulomb of charge, 12 joules of energy leaves the battery. What about energy transferred to my bulb just here? Well, again, I can use the same equation we looked at before. For each coulomb of charge, how much energy is transferred to the battery? Well, I know that my voltmeter before, when we looked at it, was reading 10 volts there. Okay, so all I need to do is substitute these figures in there. Energy is equal to potential difference of 10 volts multiplied by my one single coulomb of charge. So 10 times 1, you should be able to work out, hopefully, is 10. So I can say that for each coulomb of charge leaving the battery, 10 joules is transferred to the bulb. So finally, for each coulomb of charge that leaves my battery, how much energy is transferred to my variable resistor? Well, I know my voltmeter was reading 10 volts before, and I know for the rules for potential difference in series circuits that in that case the potential difference across my variable resistor must be 2 volts. So again, I can just put these figures into my equation because energy equals potential difference multiplied by charge. So if I put that in there, I've got energy is equal to the 2 volts potential difference across my variable resistor. I've got one single coulomb of charge, so you should hopefully be able to work that out, 2 joules. So I can say that for each coulomb of charge leaving my battery, 2 joules of energy are transferred to the resistor. So what I can say is that both the bulb and the resistor transfer energy from the battery to the surroundings. Okay, the bulb gets hot and it gives out heat, the resistor gets hot and it gives out heat, so the energy is transferred to the surroundings by both the bulb and the resistor. And when I looked at the numbers, I could see that the energy from the battery, which was 12 joules, okay, going out per coulomb, was equal to the sum of the energy transferred by the components. 10 joules for the bulb, 2 joules for the resistor. Add 10 and 2 together, we got the 12 joules coming out of the battery. So that is what we need to know about energy transfers in an electrical circuit. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.